Hello everyone, my name is Ankit Nanwal and today we will be discussing about the topic that is Varignan's principle of moments. So basically what is Varignan's principle moments of moments is that suppose we are taking this force. So this is F1 force and this is F2 force, okay. So the resultant of the force is here somewhere, okay. So we have to calculate a moment about any point. Suppose this is the O point from where we have to take a moment. So this is the distance from that point, okay. So we have force F1 and F2. So what we need to do, according to Varignan's theorem, it states that whatever the moment of this force and this force will be this is the force which is going this way and this is this way. So perpendicular distance for this force will be, you know, that moment is equal to force into perpendicular distance, okay. So according to Varignan's principle of moments, it says that whatever the forces that are acting uh, at any object, or we are considering at any point, if there are number of forces acting. So according to this theorem, the moment of all the forces, summation of all the moment force of the forces will be equal to the moment produced by the resultant force. Okay. So according to this system, we will be having that the moment of force 1 plus moment of force 2 will be equal to the moment produced by the resultant force. So this is the Varignan's principle of moments. Okay, I hope this point is clear, that moment of an force about a point is equal to the sum of the moments of a force's components about the point. Okay, so it states that whatever the summation of moment of all the forces that are producing will be equal to the moment produced by the resultant force. So this is the Varignan's principle theorem. Okay, so if we furthermore derive this point, so moment 1 will be F1 into D, that is the distance, perpendicular distance. For M2 it will be F2 into force into perpendicular distance is same here, and Mr is the moment of resultant force. Okay, so moment of resultant force produce. Okay, so from here we will get F1 plus F2 and D is common here. Okay, and what is F1 and F2? That is resultant force into distance is equal to, that is the moment. Okay, so moment of an force about a point is equal to the sum of the moments of the forces component about the point. So these all the forces are, if we are talking about this point, F1 is the and F2 are the component of Fr, where Fr is the resultant force. So whatever the summation of the moments of the component, forces component, that will be equal to the moment of an force. That is known as Varignan's principle of moments. Okay, so suppose this is the case that we are taking an example of determine the resultant of the system of parallel forces acting on the beam. So this is the case, this is the beam here, in which number of forces are acting: 80, 30, 40, 50 and 60 Newton here, and the distance has been given 2 meter, 2 meters, 4 meters, 2 meters. Okay, so where will be the resultant line? Okay, total distance is 10 meters. So first of all you have to do the summation of all the forces. So summation of forces in y direction will be 80 going downward. Suppose we are taking the downward forces as positive and upward forces as negative. Okay, so 80 going downwards and 30 is going upwards and 40 is coming downwards, 50 is going upwards, and now 60 is coming downwards, so plus 60. Okay, so this is the summation of all the forces. After solving this you will get 80 180 minus 80, so we will get 100 Newton. So this is the resultant force, and it is positive, that means the resultant force must be acting downwards. Okay, so now we have to determine where it is acting. The distance of the resultant is also need to be determined. So suppose we have taken an example here that from this A point, okay, from this A point, let us take that the resultant is acting downwards. Downwards it is acting, as this has been defined as it is coming positive, and positive we have taken downwards. So resultant is acting somewhere at a distance x distance from A point. Okay, so according to Varignan's theorem, the resultant moment will be Fr. Fr is 100 into x. This is the resultant moment that is produced by the resultant. That will be equal to the summation of all the component forces. Moment produced by the summation of all the moments produced by the component forces. So what are the component forces here? 80 Newton. For 80 Newton there is no perpendicular distance, as we want to calculate the moment at A point. So for that 80 into 0, and now you can assume that we have taken the, from here you can take that we have taken this point, resultant is clockwise. Okay, so clockwise we have taken positive, so you can also take clockwise positive, and for 30 it will be minus 30 into 2, and 40 will be plus 40 into 4. Okay, now next point will be 50, that will be minus 50 into 8, and plus 60 into 10. Okay, so this is the equation. Now you solve this, this will be 0, and it will be minus 60 plus 160 minus 400 plus 600. So you can solve this, this will give you 100, and minus plus 600, this will give you plus 200. So it will be equal to 300. Okay, 100 plus 200, 300, this will be equal to 100 resultant force into x. From here you will get x value as 3 meters. Okay, so this is how you will solve the numerical that are based on moments, or you need to calculate the resultant force, and you need to show the where the resultant is acting. I hope this point is clear. Okay, now we come to the next uh, topic, that is Lamy's theorem. So what is Lamy's theorem? Lamy's theorem says that if a body is in equilibrium under the action of three forces, okay, we are talking about three forces. When any body is under equilibrium under action of three forces, each force is proportional to the, when we are talking that each force is proportional to the sine of the angle between the other two forces. Okay, so Lamy's theorem says that suppose we are having three forces at any points, okay, P1, P2 and P3. So it states that the each force is equal to or proportional to, each force is proportional to the sine of the angle. So P1 will be proportional to the sine of angle. So जो ये फोर्स है इसके अपोजिट जो एंगल होगा दैट इज अल्फा, ओके, उसका प्रोपोर्शनल क्या होगा, P1 डिवाइडेड बाय साइन अल्फा. ओके, एंड जब हम P2 की बात करेंगे तो P2 के ऑपोजिट कौन सा एंगल है, बीटा, सो इट विल बी प्रोपोर्शनल टू साइन बीटा. And P3 का opposite gamma, so it will be equal to P3 upon sine. So these terms are equal. P1 upon sine alpha must be equal to P2. So this is stated by Lamy's theorem. Okay, so let us take this example that a sphere of weight 100 Newton is tied to a smooth ball, okay, by a string as shown in figure. Find the tension in the string and reactions are reaction of the wall. Okay, so we need to calculate the reaction of the wall. I will make a diagram here. So here is the diagram. This is the wall. Okay, here we have the sphere which is touching this wall. Okay, so and this wall is extended here, and we are saying from this center it has been tied with a rope, and this angle is 15 degree. Okay, now you have been asked to calculate the reaction of this wall. Okay, so reaction, it is supporting the this sphere in this manner, the reaction will be like this. Okay, and it is having a weight of 100 Newton. Okay, now the weight has been given. So now when we have this diagram, so first of all you will be making its free body diagram. So this is the sphere. Okay, now from this center one reaction force is going here, and one weight force, that is 100 Newton, is acting like this, and one this tension. Okay, uh, in this string there will be a tension. Okay, so when this tension is acting like this, so this angle is 50, and from here let us extend this line. If this is 15 degrees, so this angle will also be a 15 degree. So here it is 15 degree. Okay, so this is 15 degree and this is 90 degree. So total angle, this angle will be 90 plus 15, that is 105 degree, and this angle is 90 degree. Okay, so remaining angle will be this angle we are talking. So this angle will be 360 minus this is 90, and this will be so 195. So this angle will be 5 6 165. Okay, so this angle is 165. So now we have all the angles. Now you have to make another diagram that will define, so that you can apply the Lamy's theorem. Here one tension is there. Okay, here one reaction is there, here one weight is there, that is equal to 100 Newton, and this angle is 90 degree, this angle is 105 degree, this angle is 165 degree. So this is the system which is in equilibrium, acting, three forces are acting here. For calculating the other forces you can apply the Lamy's theorem. Lamy's theorem states that if we are applying this force, so this will be proportional to the sine of the opposite angle. So opposite angle is 90 degrees, so sine 90, that term will be equal to, now if we are taking W, it will be opposite to this sine of 105 degree. And then next R upon sine 165. Now we know we can derive this term, so you can calculate tension also. So now you can calculate the value of the tension, that will be equal to T upon sine 90 equal to W is 100 Newton divided by sine 105. Now you can calculate these value and you can get the value of T. Okay, that will be equal to sine 100, sine 90 and sine 105. Okay, now you can similarly calculate the value of R. Okay, so this is how you will calculate the values of the forces in case when you are applying the Lamy's theorem. So try to do the numericals. Those are based on Varignan's theorem and Lamy's theorem. So this is it for today, and the second unit is completed. So start preparing your both the unit that will be included in the midterm exam. Okay, thank you.